February, March 2020, paper 1, variant 2. Yeah. Question 1. Hmm. Diagram shows a rectangular metal sheet, okay, close to two rulers. What is the area of the metal sheet? How can I find the area? This is a rectangle. Finding the area, we just multiply the length times the width. Length times width, okay. What's the length يا شباب? The length started from 10 and ended at 45. 10 and 45. So the length is actually 45 minus 10, which is 35. The width started from 5 and ended at 25. So the width is 25 minus 5, which is 20. Length times width is 35 times 20, which is 700. This is the area of this rectangle. Okay? Yeah. Question 2. The graph, which section of the graph shows the acceleration? Which section shows deceleration? Acceleration and deceleration. Which of these sections is acceleration? Which of them is deceleration? Yalla, quite easy. Yes, acceleration is 1 and deceleration is 3. Quite easy. Speed time graph. Increasing speed and decreasing speed. Yalla, question 3. A steel ball is dropped from the top floor of a building. Air resistance can be ignored. Which statement describes the motion of the ball? Yalla. Describes the motion of the ball as the ball falls down. While the ball is falling down, what happens? Okay, let's cancel out the wrong answers. The ball falls with increasing acceleration. No, it cannot be increasing acceleration. With a decreasing speed. No, while the ball is falling, actually the speed increases. Okay, the ball falls with a constant speed. No, the ball increases. Okay, the speed of the ball increases as it falls down. So the only correct answer would be constant acceleration. Again, constant acceleration of 9.8 meters per second squared, which is the acceleration of free fall. When the ball is falling, what happens to the speed? The speed increases with a constant acceleration. Speed increases. You cannot say that the ball falls with a constant speed. This would be wrong. Okay. Question 4, diagram 1 and diagram 2. What happens? Okay, you have a flexible material. Okay, you have a flexible material and then you compress this material. Okay, diagram 2 shows the same piece of flexible material after it has been compressed so that its volume decreases. What happens to the mass and what happens to the weight? What happens to the mass and what happens to the weight as you decrease the volume? Okay. Yes. The mass does not change. The mass as you compress it. What happens? You have a couple of molecules, okay? As you compress it, what happens? The volume decreases. But the mass does not decrease. Why? Because you do not remove any molecules. So it doesn't change. And the weight doesn't change as well. Why? Because the weight depends on the mass. So if the mass doesn't change, so the weight will not change. Both of them will not change. Yeah, quite easy. On the moon, the gravitation field strength is 1.6. An object has a mass of 2 kilograms. How can I find the weight? Yalla, weight equals mg. What is the mass? 2. G, in this case, you cannot use 9.8. Why? Because you're on the moon. The object is on the moon. So the G would be 1.6. Okay, the G for this question would be 1.6. 2 times 1.6. You cannot use 9.8. Again, why? Because this question, okay, where this object is on the moon, it's not on Earth. If I say the weight on Earth, you'll multiply 2 times 9.8. But since this object is on the moon, so the weight will be much less. Okay, the G on the moon is 1.6. So 2 times 1.6 is 3.2 newtons. Okay, that was quite easy. Question 6. I need some help in question 6. A measuring cylinder contains 40 centimeters cubed of water. A solid metal ball is dropped into the water and the water level rises to 56 centimeters cubed. The mass of the ball is 80 grams. What's the density of the ball? How can I find the density of this ball? How can I find the density of this ball? Hmm. Density of the ball, okay? Density equals what? Density equals mass over volume. Okay, so you have the mass. The mass is given. Mass is given 80. Mass is given 80. Hmm. What is the volume? Okay, what is the volume? Can you say that the volume is 56? Or can you say that the volume is 40? Is that correct? Definitely not. Why? Because as the metal ball is added to the water, the water level rises. So initially the water was 40 centimeters cubed, it became 56. So the difference would be the volume of the metal cubed. 56 minus 40, 80 divided by 16 would be D, I guess. 80 divided by 16. Hmm. Okay, any questions? Hmm. Yeah, Shoaib, again, if you have any questions, please say so. Okay, yeah. Question 7. Question 7. A, a car travels along a horizontal road at a constant speed. This is the keyword. It's traveling at a constant speed. You have three horizontal forces. You have three forces acting on the car. What's the size and the direction of the third horizontal force? So you have two forces already given, and we need the third force. What will the direction and the magnitude of the third force be? Okay, we need the third force. The car is moving at a constant speed. The car is moving at a constant speed. If the car is moving at a constant speed, if the car is moving at a constant speed, this means, okay, this means that the forward force, okay, the forward force is equal to the backward force. That the driving force is equal to the resisting force. صح? Constant speed, the forces must be balanced. So the forward force equals the backward force. The driving force is equal to the resisting forces. The forward force in this case, the driving force is 1,500, 1,500 newtons forward. For the car to be moving at a constant speed, you need hmm, you need 1,500 newtons in the opposite direction as well. You need 1,500 newtons in the opposite direction. So you actually need a force, a third force, which would be directed backwards. Okay. What's the magnitude of this force? It would be 1,500 minus 300, which would be 1,200 newtons. It will be directed backwards. Why? Because now the forward force is 1,500 and the backward forces are 1,500 as well. So this car would be moving at a constant speed. Okay. The force has to be backwards. It cannot be forward. Okay. He did not say what's the resultant force on the car. Okay. He didn't say so. He didn't say what's the resultant force on the car. He said that the car is moving at a constant speed, which means that the resultant force, huh, that the resultant force equals zero. Whenever I say that the car or any object is moving at a constant speed, this already means that the resultant force is zero. Most of you solve this question wrong. Okay, usually you tend to solve this question wrong. Why? Because you simply find the resultant force, which is 1,200. No, the resultant force is zero. So the 1,200 wouldn't be forward. No, it would be backwards. Why? Because you have to balance out the forces. Okay? Hmm. Okay, yeah. Question 8. A force F is applied to a spanner, as shown. Which action increases the moment F? How can I increase the moment F? Okay, moment of F about the center of the pivot. How can I increase the moment of F? Hell, moment equals force times perpendicular distance. How can I increase the moment? Apply the force F to the end of the spanner handle. Hmm, Means apply the force at this position, at this point. Yes, this will increase the distance. And when you increase the distance, the moment increases. When you increase the distance, the moment increases. Okay. Hmm. Any questions? Hmm. A ball is released. What is the furthest position that is possible for the ball to reach? The furthest position. Hmm. The maximum position. Okay. The maximum distance for the ball. Huh. Okay. Okay. The ball will fall down and then it rises up. As it rises up, can it exceed point B? Ah, it cannot exceed point B. Again, as the ball falls down, okay? It will fall down and then it will rise back up. As it rises back up, can it exceed point B? No, it cannot exceed point B. Why can't it exceed point B? Because this is the maximum height. Okay, this is the maximum height of point B. The gravitational potential energy, okay, was converted into kinetic energy and then back to gravitational potential energy. And due to the law of conservation of energy, energy cannot be created nor destroyed. Okay, it can only change from one form to another. You cannot create energy out of nothing. Okay, there is no force added to this ball, there is no energy added to the ball, so it cannot rise above the initial point. So the gravitational potential energy initially has to be equal to the gravitational potential energy finally. That's it. Okay. It could even be a little less, which is B. Okay. It cannot reach C. It will never reach C naturally. You need to give it an extra push for it to reach C. Okay. Someone had a question in eight. Okay. Again, which action increases the moment? How can I increase the moment? Moment equals force times distance. So you either increase the force or you can increase the distance. He said that the force is F. You will not increase the force. You cannot, in this case, you cannot increase the force F. So the only choice, the only uh, solution would be to increase the distance. How can I increase the distance? By applying the force to the end of the spanner, to the end at this point. Okay, if you apply the force at this point, what will happen? The moment will increase. Okay, okay, yeah. Question 9, خلاص, I hope it's okay. Question 10. Which row describes an advantage and a disadvantage of wind turbines? Advantage and disadvantage. Advantage, no fuel needed. Disadvantage, harmful gases released. No, it does not release any harmful gases. Advantage, variable supply. How is a variable supply an advantage? Actually, variable supply would be a disadvantage. You need a constant supply. Okay, a constant supply. A variable supply means that it is not reliable. Variable supply means that it is not reliable. Okay, advantage, no harmful gases released. Okay, disadvantage, variable supply, which is not reliable. This is correct. Okay. Again, it does not, we know for a fact that wind turbines do not have a constant supply. Yes, they are a variable supply. They depend on the weather, they depend on the wind. The wind could increase or decrease on any given day. Okay, so it is a variable supply, and this is one of the disadvantages of the wind. Okay. A box of mass M and weight W is carried up some stairs, a total height of X and a total width of Y. Which quantities does the work done against gravity depend on? Okay, the gravity work done against gravity. Which quantities would it depend on? Can someone help me out? Yeah. On which quantities would the work done against gravity depend on? Hmm. Would it depend on M and Y, W and X, W and Y, X and Y? Work done. Work done is what? Work done is a force times distance moved. So, work done is force times distance moved. And I'm asking work done against what? Against gravity. Okay, so what's the force? Okay, can I choose the force to be M, the mass? Is the force M mass? No, it's not mass. No, it's not mass. So the force has to be W. Yeah, the force has to be W. And the distance moved against gravity. Distance moved against gravity means what? Means that the box is moving upwards. That the box needs to move, upwards. So the work done against gravity would depend on the height x. Would depend on the height x. If he said, for example, what is the work done against the, let's say, frictional force or the horizontal distance or whatever, okay, you would have chosen y, yes. But for this case, he's saying the work done against gravity. Against gravity means that you're picking, or yeah, you're picking the box up. Okay, the box needs to move upwards. W times x. So it will be B. Okay, I hope uh, that's clear for everyone. Okay, any questions? Question 12 is definitely cancelled. Question 12 is cancelled. Hmm. Yeah. Question 13. The skier is standing on a flat area of snow. The weight of the skier is 550 newtons. The total area of his skis in contact with the ground is 0.015 meters squared. What's the pressure? Okay, what is the pressure? How can I find the pressure? It's very simple. It's very straightforward. Pressure equals force over area. For this question, you will not, okay, you will not multiply the area by 2. Okay, he didn't say, for example, that the area of one, okay, he didn't say that the area of one of his skis is 0.015. No, he said that the total area of his skis, the total area of his skis is 0.015. So you already have the total area. You already have the total area. So the force would be his weight. Hmm. And the total area would be 0.015. That's it. You can calculate it on your calculator. Okay. It would give around 37,000 newtons per meter squared. Okay. Again, newtons per meter squared could be written as Pascal. Okay. Could be written as Pascals. Yes, that's it. The total area, and you have the force. Yeah. Hmm. The molecules of a substance in a particular state of matter move freely with random motion. Move freely with random motion. The average speed of the molecules is increasing. What is being described? Yalla, I need some help. Molecules are moving freely with a random motion. The average speed of the molecules is increasing. Hmm. What's happening? Hmm. What is being described? Huh. We have, okay, yes, definitely, ya شباب. It is a gas, and the gas is being heated. It is a gas. Why? Because they're moving freely with a random motion, fast and random in all directions. This is gas. And the molecules, the speed is increasing. When the speed increases, this means that the molecules are being heated. The gas is being heated. Yes, this is correct. Good. Hmm. A student measures the mass of warm water in an open container over 2 minutes. Okay, over 2 minutes. The container is kept at a constant temperature. The results are in the table. What does the mass of the water? Why does the mass of the water change? Why does the mass of the water change? Mass is decreasing. Why is the mass decreasing? يلا. Why is the mass decreasing? What's happening? The water, yes, that is correct. The water evaporates. Definitely. If you have some water in any container, okay, if you have any liquid in any container, it will evaporate over time. So the water does evaporate. Yes. Okay. Good. Next question. Hmm. Question 16 is kind of cancelled. Okay. Question, we know that thermometers have been removed, but again, you need to know that the 0 degrees Celsius is is the freezing point, and 100 degrees Celsius is the boiling point. You can say zero is the freezing and melting point, okay, and this is the boiling or condensation point. Okay. Okay. Next question. Greatest thermal capacity has been removed. Again, thermal capacity has been removed from the syllabus. Yeah. Hmm. Question 18. A solid is heated from room temperature. The graph shows how the temperature changes with time. At which time, at which time has it just become completely liquid? At which time has it just become completely liquid? Yeah. Which time will it just become completely liquid? Hmm. Yeah. Just, huh? Any ideas? Just become completely liquid. Hmm. At which time? A, B, C, D. Any ideas? Okay. Okay. Hmm. Okay. A is wrong. A is wrong. Why? Because this is the melting point. This is the melting point at which it will start. It just starts to become a liquid. Okay, definitely B is not correct. C, yes, C is correct because, okay, all of the liquid, all of the solid has changed to liquid. D is wrong, يا شباب. Why is D wrong? Because this is the boiling point. At D, it starts the boiling point. Okay, ماشي. Question 19. يلا. Any problems with the past question? Rods of the same shape and size are inserted through corks into a tank, okay, of hot water. Each rod is covered with a layer of solid wax that has a low melting point. Okay, after a period of time, some wax melts. After a period of time, some of this wax melts. On which rod will the sorry, on which rod will the wax melt first? On which rod will the huh, okay. Hmm. All at the same time? Not definitely not all of them. I'd say we have a good conductor, we have a bad thermal conductor, a moderate thermal conductor. Definitely, the wax will melt first. Where on the good thermal conductor? It's quite obvious. Ah, on the good thermal conductor. Okay, a boy jumps into an indoor swimming pool. He notices that the water appears to get colder as he goes deeper. As he goes deeper underwater. This is due to convection. Which statement is correct? Yell. Which statement is correct? As he moves deeper into the water, why does the water become colder? Hmm. Cold water is more dense than warm water, so it sinks to the bottom of the pool. Hmm. I think this is correct. صح. I think this is correct. Let's check the others one. Warm water is more dense. Wrong. It's less dense. The molecules of in cold water have more kinetic energy. Wrong. The molecules in the warm water are closer together than the molecules in the cold water. Again, this is wrong. Okay. So the only correct answer would be A. Okay. Hmm. Yes. Ah, this is a really nice question. Which waves are longitudinal? Which of these waves are longitudinal? Yell. Which of these waves are longitudinal? Hmm. One, two, three, four. We have a ripple tank in water. We have a drum. We have some waves on a rope. We have a spring. Which of these waves are longitudinal? Hmm. Any ideas? Hmm. Okay. Yes, definitely two and four. Definitely two and four only. This is a sound wave. This is a sound wave, and this is okay. You have compressions, rarefactions, which are longitudinal waves. Two, three is transverse, and one, any water waves are transverse waves. Okay. Any questions? Okay. You have water. Okay. Waves on the surface of the water travel from the deep to the shallow water. Travel from the deep to the shallow water. Which diagram shows the correct path? Which diagram shows the correct path? Huh. As they move from the deep to the shallow water. Yeah. Any ideas? I need some help. As it moves from the deep end to the shallow end, what happens to the wavelength? And how does the water bend? Hmm. Any ideas? Hmm. Hmm. Okay. Definitely. Okay. It cannot be C or D. It cannot be C. Why? Because the wavelength decreases. The wavelength decreases. Okay. As you're moving from deep to shallow, what happens to the wavelength? The wavelength has to decrease. So C and D are wrong. C and D are as it moves from the deep to the shallow, yes, A and B could be correct, But B is wrong. Why? Because the direction isn't this way. The direction has to bend downwards. So actually they will bend this way. Okay, as in A. They will bend. Okay, they will bend this way. So it is A. Yes. Okay, A is correct. Hmm. Okay, question 23. Which diagram shows how the light from a candle is reflected? The light from the candle, how is it reflected? Hmm. This is quite easy. Uh, This is quite easy. The image, if this is the candle, okay, if this is the candle, the image has to be on the other side. Exactly. So C and D are wrong. C and D are definitely wrong. And then the wave reflects this way. It cannot reflect this way. This is wrong. This is completely wrong. So A is correct. يلا شباب. Any questions? Okay. Which description of the image formed is correct? Huh. Which description of the image formed is correct? Huh. In 23, what's the difference between A and C? The image, the position of the image. The position of the image has to be in front of the candle, in front of the object. It cannot be all the way down there. Okay. 24. What's the description of this image? Yalla. Huh? Is it upright? No, it's not upright. It's inverted. Is it enlarged or is it diminished? Is it enlarged or is it diminished? You can use a ruler if you want. Okay. And you'd find that this image would be enlarged. Or, in other words, this object is quite close. You'd say that this is not close at all. This is actually quite far. No, it's actually considered to be close. Why is it considered to be close? Because it's between the 2F and the F. Okay, whenever the object is between the 2F and the F, then the image would be large. But an easier to solve this question a lot easier, what would you do? You can just use a ruler. Okay, if you use the ruler, you'd find the image slightly larger than the object, so the image is enlarged. In this case, the image has to be enlarged. Okay, yeah. The horn on a ship makes a sound. The horn on a ship makes a sound. The captain on the ship hears an echo from a cliff 4 seconds later. The speed of sound is 340 meters. How far away is the cliff from the ship? How can I find the distance? How can I find the distance? This is a an echo. This is an echo. How can you find the distance in an echo? Yell, some help. Yeah, please help me out. How can I find the distance in an echo? What's the equation? Hmm. Can I say, for example, can I say that speed equals distance over time in echo? Can you say speed equals distance over time? Yes. You have to say two distance. Yes, this is correct. Two distance over time. Speed equals two distance over time. To find the distance equals speed times time, but over two. Speed times time over two. 340, 340 times 4 divided by 2, which would be 680. Distance, to find the distance in an echo, speed times time divided by 2. Okay. Bats produce ultrasound waves to navigate. Produce ultrasound waves to navigate. What is a possible frequency range for these waves? Bats produce ultrasound. We cannot, as humans, we cannot hear these sounds. What is a possible frequency for the range of these waves? Any ideas? Possible frequency range for these waves for bats. They produce ultrasound. They only produce ultrasound. Which of these answers is ultrasound? Is only ultrasound? Hmm. يلا. any ideas? It has to be it has to be greater than 20,000 hertz. So the range could be from 20,000 to 120,000. Yes. Hmm. The table shows the forces that exist between magnetic poles. Which row is correct? Which row is correct? North and north repulsion, north and south attraction. Hmm, easy. Yeah. Diagram shows three different metal rods, PQ and R, inside coils of wire. Small iron nails are are placed on a wooden bench under the rods. Diagram 1 and diagram 2. Diagram 1, there was an electric current. Okay. Diagram 2, we switched off the current. Which row correctly identifies the metal rods P, Q, and R? Hmm. P, hmm, it didn't attract in either case. صح? P, it didn't attract in either case. So it could be copper. Q, it attracted when there was a current, and then it didn't attract when the current was switched off. So Q could be considered a temporary magnet, which is soft iron. Q has to be soft iron. And definitely R is steel. Why is R steel? Because it became a permanent magnet. Okay, it became a permanent magnet. The nails were attracted to the rod permanently. Okay. Hmm. Any questions? Yeah. A polythene rod is negatively charged. Yeah. It becomes negatively charged when it's rubbed with a cloth, when it's rubbed with a cloth. Which statement explains this? Why is it negatively charged? Yeah, negatively charged. The rod, negatively charged, it has to gain electrons. Quite easy. So it has to gain electrons. Again, we know that it cannot gain or lose protons. Hmm. This is an emitter. What's the reading on an emitter? Such an easy question. What's the reading on this emitter? Yeah. What is the reading on this ammeter? Huh. Yeah, I need to see your answers. What is the reading on this ammeter? Uh, okay. Hmm. Can someone say 0.45? Uh, definitely wrong. Uh, okay, 5. Yes, it is 5, Shabab. It has to be 5. Yes, thank you. It has to be 5. Yes, it has to be 5. Why? Because it's in the center between 4 and 6. It has to be 5. A lot of you actually other students chose 4.5, which was wrong. Okay, 4.5 is definitely wrong. Yalla, question 31. Which circuit is used? Which circuit could measure the resistance of the resistor R? Hmm. Can you add the voltmeter in series? No. Can you add the ammeter in parallel? No. Can you add the ammeter in parallel? No. So the only answer would be D. Hmm. Yep. Question 32. Diagram shows a battery connected to two resistors. Three ammeters M1, M2, and M3 are connected. Ammeter M1 is 1 ampere. 1 ampere. What are the readings on M2 and M3? This is a series circuit. Huh? Series circuit. Current has to be constant. The current is the same in any point on the circuit. It has to be D. Yes, it has to be D. The current cannot change. The current cannot change. Why? Because this is a series circuit. Lamps in a circuit are connected in parallel. What is the advantage of this? Advantage of connecting lamps in parallel. يلا. If one lamp breaks, the others remain it. This is correct. صح. Okay. Okay. Good. يلا. Bravo. Question 34. We have a relay. Okay. A relay. A very rare question. Relays are very rare. But okay, let's see. What is the function of this circuit? What is the function of this circuit? We have two circuits actually. Circuit on the left and the circuit on the right. Shows a relay being used to control a buzzer. So this is a buzzer, okay? This is a buzzer. Okay. A relay is being used to control a buzzer. What is the function of this circuit? Okay, the buzzer switches off, or switches on. Okay, well, definitely. Actually, the buzzer is now off. Why is the buzzer off? Because the switch is open. So initially the buzzer is off. So the buzzer switches off. لا, it switches on. Okay, the function of the circuit would be to switch on the buzzer. The function of the circuit would be what? To switch on the buzzer. Type. What is this component? We know that this component is an LDR. What's an LDR? A light dependent resistor. A light dependent resistor. A resistor that depends on the light. It depends on the light inversely proportional. What does that mean? As you increase the brightness, what happens to the resistance? It decreases. As you increase the brightness, what happens to the resistance? The resistance decreases. So it doesn't depend on the weather. It doesn't depend on whether it's hot or cold. It depends on whether it is bright or dim. As it becomes light, as the brightness increases, okay, the resistance decreases and the current increases. When the current increases, the magnetic field increases, and then the switch is closed, so the buzzer switches on. Okay, the buzzer switches on. Any questions? يا شباب any questions؟ ماشي. We have a 5 ampere fuse. We have a 5 ampere fuse. What is the purpose of the fuse? يلا. For the 100th time. What do we do with it? What is the purpose of a fuse? يلا. For the 100th time. What is the purpose of a fuse? What does a fuse do? It breaks the circuit. It breaks the circuit if the current is less, when the current is greater. But again, on which wire do we connect the fuse? It's not on the earth wire. It has to be on the live wire. Okay. The fuse, the switch, okay, they are all connected on the live wire. Okay. Hmm. We have a transformer. We need to find the number of turns on the secondary coil, which is the NS. Yep. We have an equation, only one equation, VP over NP equals VS over NS. Do we have the VP? Yes. 240 over NP, 1000, equals 12, which is VS divided by NS. Simple cross multiplication, 1000 times 12 divided by 240. 1000 divided by 12 divided by... Hmm. It would be, yes, it would be C. Okay, it would be C. Okay, good. Question 37. We have a current carrying conductor. Okay, we have a wire with a current inside, which is placed inside a magnetic field. And the force on this wire, in this case, okay, the current is moving this way, okay, and this is the north and south poles. These are the north and south poles. The force on the wire is upwards. So this wire is moving upwards in this case. Which arrangement, okay? Which arrangement or which arrangements would cause a force on in the opposite directions? Which arrangements would cause a force in the opposite directions? Any ideas? How can I cause the force to be in the opposite direction? Yeah. What are the two conditions, okay, for which the force can be in the opposite direction? If you reverse the current, which it would be in the opposite direction, the force would be downwards. Yes, this is correct. If you switch the magnetic field, if you switch the poles of the magnet, okay, north and south, now it will be south and north. Okay, the force will also be downwards. So this is correct. But in R, you switched the force, you switched the current, and you switched the magnetic field. You switched the magnetic field, oh, south and north, and you switched the current. So the force on this wire would be upwards. Okay, the force on this wire would be upwards. Again, he wants the force to be in the opposite direction. So the only cases in which the force would be in the opposite direction would be if you change only the current or if you change only the magnetic poles. Okay, either or. Okay, I hope this is clear. How many neutrons? How can I find the number of neutrons? 14 minus 6, 8. Number of neutrons, very easy. Hmm. Okay, student measures the rate. Okay, which type of ionizing radiation is being emitted by the substance? Okay, we have a distance d between the source and the detector. Okay, between the source and the detector. When the source was very close, the distance was zero. When the source was actually touching the detector, the reading was 1,250. When you moved it a distance of only 2 centimeters, huh? You moved it a distance of only 2 centimeters. What happened to the reading? Decreased, 115. When you moved it a distance of four, okay, of 4 centimeters, when you moved it a distance of 4 centimeters, what happened to what happened to the reading? The reading became zero. When you moved it a distance of 4 centimeters, okay, to zero. And then six, it's also zero. Which of these radiations, okay, which of these radiations is being emitted by the source? Which of these radiations cannot travel far distances? Actually, 4 centimeters is not that far, I know. Okay, but which of these radiations cannot travel far distances? The distances are extremely short. Which of these radiations? Gamma radiations, no, gamma radiations actually have a gamma can actually travel for several kilometers. Okay, X-rays will just cancel it out. Is it alpha or beta? We know that alpha is the shortest range. Alpha has the shortest range. In this case, it can only travel up to 2 centimeters. 2 centimeters, extremely short. Okay, an extremely short distance. Okay, ماشي. Alpha particles. Last question. Again, what's the half-life of the source? What's the half-life? How can we find the half-life of the source? We just divide. Take the initial number, we divide by 2. 2,000 divided by 2 would be 1,000 from the graph. 1,000 would be 1 hour. Okay?